and we're going to talk about function definition. So we're going to talk about a function. A function is a relation or a set of points such that for every x, there is one and only one y. So in short, the x values cannot repeat, but the y values can. So the x values cannot repeat, but the y values can. But the y values can. Okay, so let's look at a few examples. The other way that you can identify a function, honestly, it's called the vertical line test. So let's use the vertical line test. Vertical line tests. Okay, so the vertical line test. So we're going to draw two things here. The first one is going to be something like this, which is a very famous function called a quadratic. Right? With a quadratic, such as y is equal to x squared, basically, if I was to draw a vertical line down any part of this function, notice that it only touches the graph once. So it passes the vertical line test. The x values, so let's say this was -2, -1, 0, 1, and 2. The x values are not repeating. If I was to write down the set of points for this function, you could have something like -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. Your x and y values, there's very unique values there. So for every point on that, the vertical line test, it only touches the function once. But if I draw a graph like this, that means at this point, let's call this point -1, it fails the vertical line test. So it fails the vertical line test. What that means is that it's crossing the function twice at the location of x is -1. So then it's like, what is the value then for -1 when I input when I input -1, what is my y output gonna be, right? So this is not a function. This is a function. Function, right? So this is a function here, and this is not a function. Well, we can do it like this. Okay, we're gonna start using different colors of marker here. So we have the definition of a function given in your book, and then we have a simpler definition, which is simply that the x values cannot repeat, but the y values can. Because in this case, notice that when you have -2, you're going to have a 4 equivalent, and when you have a 2, you're gonna have a 4. So -2 and 2 give us a value of 4, but a quadratic is a function. But over here, -1 is giving us two different values, so it's not a function. When you fail the vertical line test, you're not a function. When you pass the vertical line test, you are a function. So they give you a few examples and ask you questions about, are these functions, right? They give you examples on page 84 of the College Algebra REA book. They go on and explain the vertical line test, and then they explain that you have a graphical representation of a function. You have numerical representation. So you have numerical representation where we're giving you those domain and range x and y values. We have a graphical representation of functions also given in your book. The next big thing that your book talks about is function notation. And in a lot of my videos, you will notice that I bring up mathematicians a lot, right? And this is a very famous notation we use in math called f of x. So we say there's f of x, and basically it's the same thing as saying y for something. And your book gives you an example. I'm going to give you another example, but let's say they give you 3x cubed plus 2x squared. It's the same thing as like that. These are the same thing. This one is saying f of x, and this one is saying y. What is interesting though is the guy who came up with this is my guy, all right? This is my guy, Leonard Euler, right? So he came up with that notation, which is really cool. So if they give you f of x is equal to something, and then we say what is f of 3, that would be 3 into 3 cubed plus 2 into 3 squared. So notice that you substitute the value of 3 everywhere you see x in the original function. And so this becomes f of 3 is equal to 3 times 27 plus 2 times 9. And all you have to do at this point is say what is, so 3 times 3 times 3, that's how we get that cubed. That's how we got 27. And then 3 times 3 is 9. We multiply those two together. We know that's 18. We multiply 3 times 27. That's 81. 18. That's really cool. I just picked this problem randomly, but how cool is that, right? That's the percent I hoped I could get in school all the time, but didn't always happen. 99% is really cool. 100 is better, but 99 is great too. Anyways, so 99%. If you get 99%, that's like excellent. Anyways, back to the problem. So this is function notation. F of x means that you have like a value that you can plug in for x. That's what you're doing. That gives you the values. We're good. Let's move on then to a practical application of this idea of function notation, which I think your book does a good job of. And what they do is they explain that, think about function notation in terms of a formula. Think of it like how we use formulas. So using formulas. Okay? When someone gives you a formula, the idea then is that you should be able to substitute the values in that make that formula work. So let me think of some of my favorite formulas. Well, actually, the one your book uses, they give you formulas like pi r squared, which is the area of a circle. In chemistry, we have a lot of formulas, right? Actually, how cool is that to be able to transition into a formula from chemistry, right? So if I say P1 is 5, and V1 is 10, and P2 is 10, and someone says, what is V2? What you do is you plug the values in and solve for the unknown, right? So basically, this is, let's just call this X. So X is equal to P1 times V1 over P2. So that's 5 times 10 over 10. So X would be equal to 5. That's V2. So you're using a formula, and this is going to happen in chapter 15 of your book. This is going to happen in chapter 15 of your chemistry. So now, we're talking about math, but notice that function notation is actually in chemistry too. So in chemistry, when you talk about Gibbs free energy, when you talk about entropy, you're going to be given a formula, and you need to be comfortable solving with that formula. Let me end with one formula for you. Let's use pi r squared here. If a is equal to pi r squared, and I tell you that r is 10, that means you substitute a is equal to, and let's just use pi as 3.14 for today. For those of you who memorize pi to 1,000 digits, have mercy on us. We're only going to use 2 digits. This will be 3.14 times 10 squared. What is 10 times 10? 100. 100 times 3.14, and let's call this centimeters. 100 times 3.14 will make it 314 centimeters squared. Functions are applicable, like function notation, the idea of a function on an input value and an output value can be used with formulas. Chemistry and physics have a lot of formulas. So notice that math and science, they used to be one, like one thing together. Like you think about physics and mathematics in the 1700s, they were together. Isaac Newton was a physicist and a mathematician. So let's be very careful when we try to separate math and science. They're actually more integrated than you might realize. I hope this was helpful. Have a great day.